Mars or whatever. So they all will be having, you see, the evidences, okay, that when that moon was formed, because they don't have atmospheres, so one can get some kind of an idea, okay, like how our planet system, the solar system has come into picture, how things have progressed basically. So this is a planetary geology or this is a planetary seismology. Of course, there are a lot of objectives are there. Whether life is there, that's a different issue. But as far as this course is concerned, say, we are more interested to know about our Earth only. Okay, that is our main objective. But we are looking at indirect kind of thing. So instead of digging down and then try to understand, so we are looking up to the sky like moon and other kinds of things. Looking at the rocks or the impact craters or volcanism. Or quakes also. Okay, so after that, we try to draw some kind of inferences for our planet. So this is a main basic objective, of this planetary seismology, this course itself. So now, you would have seen, he would have explained you a lot of, the nice, he would have given you all the slides that James had, how the planetary exploration and all those things also. Let us see. Yes. So I will just select these slides. Yes. So you are able to see the slides? No, slides are visible.
Yes, sir.
Yes, sir.
So you can read also, right? Everything is visible, no? So anyway, so now if the slides are visible, say, okay. So now you can see here. Okay. Anyway, before we go into this, this itself. So the first thing is, most of you should understand some units are there. So generally in our the planetary sciences, generally in our engineering, we talk in terms of kilometers or meter per second or something like that. But in these planetary things, we will be using some type of units basically. So one is the distance, say. So we talk in terms of astronomical unit basically. Okay, that is AU. So this is how we define. So this astronomical units, the broad definition is we define as, you see, the average distance, say. Okay. So between the center of Earth and the center of the Sun. So this is what we call as the one AU, astronomical unit. So it is basically a distance between the center of Earth to center of the Sun. So this we call as one astronomical unit itself. If you want to know the exact mathematical definitions given in physics or astro, this one, so they define like this actually. Semi-major axis of massless particle, whose orbital period about the Sun is 1 year. Okay, that's the same as Earth only, because our Earth also the periodicity is 1. So this is exact definition basically. Okay, so of course it's slightly Earth is larger than 1 year, but anyway, we are not in this, as far as this course is concerned. So we are not interested in this, astrophysical kind of things. So generally our definition as far as this course is concerned, so 1 AU, that is a distance we call. So that is basically the distance between center of Earth to the center of Sun itself. In reality, it will be slightly larger, but this is what our definition is. So this astronomical unit, say, this is how, if you want to write in terms of kilometers, so one astronomical unit is 149.6 into 10 to the power of 6 kilometers. So this is what we call as 1 AU. Okay. Then of course these are the units which we will be using when we are talking about our solar system. Okay, like distance of Neptune or distance of other planets. So we write in terms of astronomical units. But then when you go away from the galaxies, say, so our Milky Way galaxy or stars and whatever this one, so what type of units people use? How do they measure the distance? No. So you would have studied, right, in your school also. So we use, what are the units basically? No.
Light year.
Light years we use. All these things itself. Okay. So 1 light year means the distance light travels to the vacuum of interstellar or galactic space, say, in 1 year basically, in one sidereal year at a speed of 29979 into 10 to the power of 8 meter per second. So finally, so the 1 light year, say. So this is a velocity multiplied by 365 days. Okay. So the multiplied by 24 hours multiplied by 60 minutes and then 60 seconds actually. So finally, this is what, the light year. So these are the units basically. So 1 light year is 946 into 10 to the power of 12 kilometers. So this unit generally is used for to calculate distances of the faraway stars or something like that. But when you are located in the solar system and if you're interested inside, we use this astronomical unit. Okay. So these words, if you see any textbook on planetary sciences, so they will be using these units basically. 1 AU, like you say 20 times AU, or if they talk in terms of stars, say, so they do in terms of light years, 10 light years or something like that. So these are some fundamental, the units, which of course most of you will be, you have already studied, but just to keep it in your mind. Okay. And now what happened in our planetary, this geology or planetary seismology, now in the 16th century and then 17th century, say, so this is a Copernican, Galileo, Newton, many intellectuals you followed, right? They started, like, they have put a telescope. You would have seen Galileo, right? Some telescope they saw, and then they saw about our solar system, and then they made some comments also, like, what is the mass or whatever, how this orbital periods and others, this subject started evolving basically. Okay, I will show you what has happened before also, but this is what it happened. And then slowly, the next century is say, so we had so much of innovations happened, and then we had this space age basically. Okay, so the first page, the planetary explorations, it started from October of this 1959. Okay, so you would have seen the James Head lecture also. So right, what was the first spacecraft, who launched, US or USSR? Yeah, you have studied, right? In this lecture also, would have shown you that sound also, that Luna 3. So this was, of course, they first sent it to space, and then they started this Luna 3. Okay, so which went for the first time, say. So we saw the first pictures. Of course, the pictures are available in Google also. They are not of high resolution or whatever. So this was the first picture we saw from the moon. That is the far side. The moon which you are seeing from right now through your naked eye is what we call as the near side of the moon, but far side means we can't see that far side. So this was the first time USSR attempted, and then from 1959 onwards, say, so this age of planetary exploration basically started basically. And then, right, this US and USSR, say, so they had a Cold War, and all kinds of things happened. But the one good thing with this Cold War, say, so there was a huge competition, and people started a lot of technological advancements, they took place actually during this planetary, this space age basically. Okay, so they launched spacecrafts, competition was there, and then they have launched spacecrafts, I think, to almost all the objects in our solar system. So I think almost we have visited all the the planets and all whatever things are there, at least in the solar system. So right, what is that spacecraft which has gone outside our solar system? Yeah. So any spacecrafts have gone out of our solar system? No. So which are the spacecrafts? Two spacecrafts, right? Very famous. They have now left our solar system also. What are those? Do you know their names? So what are those spacecrafts names? Which has gone out
Maybe
of
Voyager 1.
Voyager 1 and Voyager 2, both they launched, I think, some 1978 or something like that. Now I think they have gone into interstellar space itself. Okay, so these spacecrafts, so they have given sent, when they really from the left our solar system, they took all the photographs actually of all the planets and moons, and then they have even created, a family portrait basically. Okay, so we don't have a picture of all the planets in the solar system in one camera, because if you want to take a picture, so you have to go far away from the solar system. Then only you can see all the planets, and you can family portrait, they say. Okay, so this has this Voyager 1, Voyager 2, I think still they are moving. So they are giving a lot of informations also. So all spacecraft. So now you name any object in our solar system. So definitely some say spacecraft by US or USSR or somebody else would have visited, and now we are having a lot of photographs and a lot of understanding about this the solar system. So now so previously earth is previously whatever we know from our solar system, say, is through only telescopes actually. Okay, so but now spacecrafts have expanded basically. So now we have lots of images, lot of data from this one. Okay, so now we have, I think, these spacecrafts also, they will have lot of instruments basically. Okay, electromagnetic spectrometers, radio signals, X-rays, gamma rays, all kinds of instruments will be there. So they have they have detected a lot of the new information, like what type of atmospheres are there on those planets. So all these details, magnetic fields and other things, so we have all these informations also. So now if we see our thing, so now nowadays the planets and satellites, now they are much more familiar to us, compared to the previous, like 50 years back, whatever we know, say. So now we are much more confident about all these numbers itself. Okay. So now previously, see, so now I will show you. You also would have seen, and I will also show you some photographs also, which whatever we thought about that a planet say, the complete it gave a different type of opinions, a different type of understandings, of this space race basically. Okay. So these are some the aircrafts. Okay. So which like which have gone to moon basically. This is available in the textbook. You can get it in Wikipedia also. So Luna 3, that was the first spacecraft basically, which was launched to moon. So which just got a photograph actually of the far side of the moon. Then Ranger 7 US launched some 4,000 photographs was clicked, and all these data sets are available actually. Okay. And then if you see the recent ones, a Grail basically. So they have done the gravity mapping of the moon itself. So we know the acceleration due to gravity, say, for the entire moon, and how this gravity changes, say. So this was brought by Grail, and so many missions are being planned. Now, if you see for moon, say, the recent, the latest mission is Artemis. Okay, so I don't know how many of you have heard. So NASA is sending some, once again, the astronauts actually. Okay, to this Artemis, maybe in another 2-3 years, say. So they want to mine the moon, and then there are a lot of papers have been published, trying to identify the locations where we can stay safely. Okay. So where the that some tunnels have been found out in moon, and then they are trying to do the design also, like we know design of steel structures, right? How to design a house, or how to design a frame, we have studied now. So now already a paper has been published, like in Journal of Aerospace Engineering, where they have designed the lunar capsule. Okay. For impacts, as well as for moon quakes and other things also, a steel structure where people can stay, and then they can do whatever experiments or whatever things like that. So now so our understand, then we also have rocks from moon also. So Apollo programs, people have gone there and they have brought rocks from the moon. And then Apollo 12, or I don't know, some missions, they have conducted even the MASW test basically. That is, they have put up the geophones there, and they have even collected the data of moon quakes and impacts on moon. A lot of information to say. The velocity models, a lot of details have become available basically from the moon. So now moon or other planets, say, now they are no more astronomical objects; they are basically geological objects, and our understanding has also, we have now in a better position, say, to tell about these planets. So now anyway, so now and apart from that, you see the Saturn rings, so this was also everybody knows, now I don't know how many of you know what was the recent spacecraft which went to Saturn. 2 years back, it was a very popular spacecraft. Can anybody tell us the name? It has given lot of photographs. It has taken told us about the new moons of Saturn also, and finally the spacecraft is it collapsed into Saturn actually. Okay. So while collapsing also, it sent huge photographs basically of the Saturn atmosphere. It took a lot of photographs before it got destroyed on the Saturn itself. So can anybody know the name of the spacecraft? Very
Cassini. Sorry.
Yes, excellent. Okay, so I think you are reading nicely. Okay, fine. So Cassini spacecraft. So a lot of information came from Saturn. Okay, so now I will show you some photographs also. New discoveries or new concepts. Has come up from this Cassini also. Then right? People have sent, I think, spacecrafts for asteroids. I think there was one deep impact or some mission was there where they wanted to. I think. They've done impact an asteroid, or that also has been sent, and a lot of photographs have come basically. And then recently, right, NASA has sent a mission to Sun basically, because Sun is a huge temperature set. They have designed a very sophisticated spacecraft. It has some shield in the front actual, and the backside it takes photographs about the Sun and taking the measurements also. Like I think our ISRO also has some missions maybe. Okay, for Sun and other things also, the solar wind. Okay, so the people wanted to find out how much far distance, what is the influence of the Sun basically. Okay, so Sun we have, and how much distance the Sun will have influences. So this is also a very important concept came, and then lot of spacecrafts have been developed for this thing itself. Okay, so this also is a very important thing. Then even the Sun's gravitational things, so it extends people have found out that it can go up to the Neptune or whatever here. So all these information has been spacecrafts have launched, and then the information has come up actually. Okay, but now still that is fine, but the outer regions of the solar system so that has not been poorly explored, and many there are still some more planets maybe there apart from whatever 8 planets we know. So that's still Voyager 1, Voyager 2 left, but still these things are getting probed. So now we know nicely information up to maybe up to Neptune or whatever, and Pluto also we have a photographs, and then things are going on. Now there are hundreds of planets basically apart from our solar system. There are a lot of planets which are orbiting. You would have studied, you would have seen in news also. Apart from Sun, there are a lot of stars are there. So many planets are doing this circling those kind of things also. So like you see now some properties also they are there. Okay, and then of course biology is a very important, and whether life is there or not, microbes and all other things also. So these type of things are also going on right now in the planetary the domain. Okay, so now here what has happened was so there's a planetary sciences so it is basically subfield of astronomy we say. Now some exposure to solar system studies is an important component to the education of astronomy. So if you want to become astronomer so that you should know the solar system and other things also. And this planetary sciences basically it has a close relationship with geology, geophysics, atmosphere, space sciences. All these things have come up. Like what is atmosphere on Mars? How atmosphere has evolved. This one, geophysical things. How Mars has evolved. Whether it has any inside core mantle or some magnetic field or something else is there. So this has also has come up basically. Okay, and of course the properties of planets is they are very, of course, astrobiology. This is anyway everybody is curious whether life is there or not or something like that. So all these things have come up basically because of this lot of advancements in technology, and lot of spacecrafts have gone, lot of instruments so this has happened. So now let us understand our solar system. Just a brief thing about our solar system. So you can get these details in Wikipedia or that textbook, whatever textbooks I think Meenakshi has shared in the group. So that also contains. So we will just go through briefly, what is how what are the there in our solar system. Some more details basically. So now if you see our solar system, so we know that our solar system has the one star here, that is our sun. Then we have 8 planets, and then we are having several moons basically. So Earth has one moon. Other planets also has a lot of moons are there. Then there are also dwarf planets basically, like Pluto. Is no more considered as a planet, and it is what is known as a dwarf planet. And then there are a lot of other bodies are there, like asteroids. Between Mars and Jupiter, you will see asteroid belt is there. Then we have comets, which are in after this Neptune. So Cooper belt objects as Oort cloud, scattered disk, so all these things are there in our solar system. Okay, so now let us see these things in detail. Now in the olden days, basically, okay, the olden our Indian mythology or whatever, even the Greek mythology or whatever we have studied in our Puranas or in the old people. So what type of model they used to use? No. So can you know this geocentric model? No. So what do you mean by geocentric model? So this was a thing which was preferred in the olden days. This type of the coordinate system actually. So in this geocentric model, so what is the origin?
Earth is the center.
Earth is at the center. So Earth itself is our origin basically. Of course, this was very easy, because in those days they don't have the technology of sending spacecrafts or whatever. So the easiest thing is, so you just take Earth, ourselves as an origin, and then you observe in the sky basically. Okay, and you locate all the positions of the planets or stars or whatever, and they used to construct actually. So they used to call this as like this is what they call a celestial sphere basically. Okay, so Earth is at the origin. So this is our Earth. Okay, so this is my origin. So this is my north pole and south pole, and this is my equator. So what people used to do is they used to draw a sphere actually around our Earth itself. So this sphere is known as celestial sphere basically. So now because all the stars or whatever say, because in those days they don't know how to measure the distances, and that great detail was not there. So what they, and the distance was not important for them actually in the olden days. Okay, so they assumed that whatever you are seeing in the sky say, they're all located at equal distance actually, basically from our Earth itself. And they used to posit all these stars, whatever you see in the sky, on this celestial sphere. And they used to find out the origin, coordinates, positions, and others. They used to measure this geocentric model. So this model also works very nicely now. Also, still people are using. So here, we are not interested in the distances. We are just interested in the position actually with respect to Earth. So this is what they call as geocentric model. Now also it's perfectly fine. And right, our astrology say. So whatever you would have studied in our astrology also. So Earth is taken at the center. So our geocentric model only we use. And then they used to do these lunar mansions basically. So they used to find out, you see, the moon set today where the moon is, and then this is 360 degrees basically. Okay, so moon also travels 360 degrees in the celestial sphere. So this whole 360 degrees. So they have divided it into some 27 lunar mansions. They say initially some 28 was a Abhijit one nakshatra, so that has been thrown out actually. We don't know what, we are not interested in those things. So 27 lunar mansions was there. And then each mansion say, so this each house they gave that nearby stars like Ashwini, Bharani, you followed it, Kritika, all those stars was there. Okay, so 27 was there. 28th star was Abhijit. Okay, but that has been removed right now. Okay, in our astrology or whatever this one. So this was the thing which was used in the olden days. So the star system say, was done from our Indians actually. Okay, then the Greeks, if you see, they divided this into some these 12 zodiac signs or something like Aries, Taurus, Gyrus, or whatever they used to do. And then and then they used to measure basically. So like for example, where will be moon today, their positions say they have noted down nicely using this geocentric model. And then right, that they used this to find out your birth star. So like for example, if you're born on the some day say, so on that day where moon is located basically. So if moon is located in this portion say, so that means your birth nakshatra Revati or something like that, and each nakshatra, so 360 degrees say. So 360 divided by 27, approximately some 15 degree, 30 minutes or something like that it comes. So this nakshatra is something like, a square kind of a thing. And then this has been used widely in, this astrology and others also. But this was also used to find out, the ephemeris they say, like where moon will be located, what time, where it will be located. So these calculations they used to do in the olden days. Because in the olden days we don't have the technology to go to the moon and other things, so they were not interested in the geology of this stars or the geology of the planets. They were interested only in their positions basically, astronomical positions. And this is how this old model came up, the celestial sphere and all other things. Now right, what is this pole here? Can anybody tell me? The celestial sphere say, so this is our north pole of our Earth. So if you project this celestial pole towards the north say, okay, so you will have this north celestial pole, and then south celestial pole will be there. And our north celestial pole say, it is located where, which is a star which is close to our north celestial pole in our Puranas.
Pole star.
Which one?
So pole star. That
Pole star.
yeah.
Of course, in our Puranas we don't call as a pole star, we call as
Dhruv Tara.
Dhruva star. So what is the speciality of this north celestial pole? Because our Earth rotates like this, our Earth axis is inclined 23.5 degrees basically. So our Earth is rotating say. So now the advantage of this north celestial pole, this star basically whatever you see here, so that star appears constant actually. That star will never move, whatever day, today, tomorrow, whatever, so that used to be there. So they used to take this as a Dhruva, and then all others say they rotate around this star itself. So that was the coordinate system which was used in the olden days. Now also people are using. Still, it is a very useful information. If you are not interested in geology, if you are interested only in the positions, ephemeris, and other things, say. So this thing is widely valid also. Okay, but our planetary geology, we don't now these things, we don't use basically. Okay, because now we know the distances of the planets, we know all the like astronomy, AU, and then light years. So that has been now thrown out actually from our the modern planetary sciences. Okay, so now if you see that's what, so then geocentric view gives this is fine, but it gives a distorted picture because the distances, we are assuming that all the distances are same. So distance from Earth to Mercury is also same, distance from Earth to Sun is also same, distance from Earth to Moon is also same. So that is how the geocentric model works actually. So now the best thing now people is what is seen by an objective observer from far. So if you are looking at our solar system from far away, say, then how does it looks like actually? So this is a new coordinate system, which has come. Okay, so there's obviously now you see the sun, which is at the center. That's what is that is a fact. Around the sun, everything is revolving here. So now the sun has a luminosity, say 4 into 10 to the power of 8 times as large as the total to luminosity of Jupiter. Luminosity is how much light it will show. So there's the most brightest object is the sun itself. And the second brightest object in our solar system is, of course, the Jupiter. You can see nighttime, in the sky, say, Jupiter shines very bright actually. Okay, and then if you do generally in our in our analysis, like even in our mechanics of materials also, or if you have large amount of dimensions, say, what we try to do is we try to find out the eigen values actually. Okay, so like for example, we are having how many objects in solar system, like 8 planets. If you count asteroids, if you count this one, say maybe 1 million particles are there in our solar system, say, and then you find out the eigen value analysis, and then try to find out which is the most influential thing in our solar system. So obviously, and if you go by mass of the solar system, say, so almost the sun contains how much mass of the solar system? Yeah. So you can see how much is this mass?
99.8.
So what does it mean? So 99.8%, the solar system is covered by sun itself actually. So now what is your comment here? Yeah. So what does it tells you? So if you do eigenvalue analysis, okay, you would have studied eigenvalue, eigenvector, or the natural frequencies in dynamics course also you would have studied. The first natural frequency, it explains 99% of the data, like that we try to do here. Or the first principal stresses, say, it will that will be the maximum value. Then we have second principal stress, third principal stress also. So the largest one, say, so if you go by this eigenvalue analysis or this type of analysis, so what it appears is the solar system means a sun plus the remaining, say, 0.2%. So that is whether that is significant.
No.
See, by going by these numbers, say, what is more important here in the solar system? No.
Sun itself.
Sun itself. So which means the remaining, say, whatever planets, whatever things we are talking, it is all debris actually. It's all useless kind of stuff itself actually. Okay, so this goes by our in terms of masses basically. But of course, if you write in terms of angular momentum, say, in the solar system basically, so angular momentum, what happens is the angular momentum, right, that mr and omega, because all the planets are rotating, the orbits are rotating in the orbits, but 98% of the angular momentum, say, on the solar system lies in the orbital motion of the planets basically. So this is a very, very important thing. So if somebody says that the Earth, all planets are all useless, going by just mass. So by mass, Earth, all planets are useless. Only Sun is only very significant. But if you go by other measures like angular momentum basically, so now what happens when you go by angular momentum? So 98% is contributed by what? All the masses are very, very small, but why the angular momentum is become very high?
So because they are rotating and revolving around.
Rotating, revolving, but what is happening? Right, momentum. So when you do momentum, say, that mass into that distance kind of thing will be there, and the planets are located at large distances. You have seen, right, one astronomical unit or whatever, all the mass is small, say, but distance is so huge. So what happens is that creates a large angular momentum basically. Okay, so now this is so if we go by angular momentum, so still our Earth has planets are very significant actually. Okay, but compared to mass, planets are useless. Sun is the best, but this is how you can get this one also. Okay, so Sun is, of course, they say, and of course the Sun is a very different thing, which all of it is basically, it is not even a planet, a ball of plasma powered by the nuclear fusion at its core here. And then so the Sun is slightly different from other things, which anyway okay. And now the debris, say, which is encircling the Sun, that is what we are calling as debris. All the planets are debris only if you go by in terms of mass. So this consists of all the planets. Say, you can classify them into all the objects actually in the solar system apart from Sun. We can classify into 3 groups actually. One is the giant planets or the Jovian planets also. Then the next one is this terrestrial planets, which are very important we will be studying this in great detail. And of course we have numerous small objects also, like a comets or asteroids or something like that. Okay, now these giant planets say, so these Jovian planets, we say they dominate our outer solar system. So if you see here, this solar system, if you see this figure, say, so now here where the most important planets are located, giant planets are located. So these planets, say, that is Mercury, Venus, Earth, and Mars basically. So their sizes are very small actually. So these four, we call them as the terrestrial planets, because anyway rocky, we will give a better definition after some time. So the jovial planets are the huge planets, that is a gas giants, we say. They are located in the outer solar system actually. Okay, of course outer means you can ask what do you mean by outer, how much distance and others also, but generally they dominate they dominate our solar system, that is Jupiter, Saturn, Uranus, and Neptune. So these are the very huge planets which are in our solar system. Okay, so now let us see this detail. So now these what the inner solar system say. So the inner solar system, that what they call is up to Mars basically. So sun is here, so we have Mercury, Venus, Earth, and Mars say. So this inner solar system, it is dominated by the terrestrial planets. Okay, that is a rocky type of planets itself. And then the outer solar system say, so that is what is shown here. So you can see Jupiter, Saturn, Uranus, Neptune, and of course Pluto is now not even considered as a planet, it's just a dwarf planet. So these are the outer planets. So this is what they call as jovial planets, and these are the terrestrial planets. And of course Pluto, its orbit is inclined. We will see this in after some time. Okay, so now the Jupiter say, so in our solar system, apart from sun basically, sun is the most dominant. The next thing, if you try to find out, so Jupiter is the one which dominates our planetary system, and its mass is we can write in terms of Earth, like 318 times Earth masses actually. Okay, and of course it exceeds twice that of all other solar system planets combined. That is a huge mass of the Jupiter basically. Okay, so now so if you go by in terms of second approximation or in the Taylor series, okay, the first term is sun itself, 99.8% is explained by sun. The next ones, that is H into F dash X or whatever, that is dominated by Jupiter basically. Okay, so sun, Jupiter, and then some debris. So now the third term in the Taylor series is nothing but our Saturn comes, okay, with a mass of 100 times Earth masses basically. And of course these are all made of hydrogen, helium, and other things also. So they are all gas giants basically. Okay, and maybe nobody has known because the pressure, you can't land on them. Okay, because there is a huge pressure and it's all atmosphere itself. They say that they may have a huge core of mass actually, but what the material that core is, some people say it may be some different material or diamond, something. We have no idea actually. Okay, what type of core they have. Now in the Taylor series, the first is sun, then we have Jupiter, then Saturn, then we have Neptune, and then Uranus actually. Okay, so these are the four terms we'll have. So their mass is something like 1/6 of Saturn, and this Jupiter and Saturn say. So these two planets are basically gas giants, they say, full of gas, and this one. But now when it goes to this Neptune and Uranus, say, apart from they are no more gas giants basically. So they are all ice giants, we say. So like they contain a lot of water, ice. It is stored in the form of ice, ammonia, then methane, and of course rock also. Now the photographs have given a solid proof of this one, because of the temperatures, very low temperatures. So they are known as the ice giants basically. So generally Jupiter and Saturn, we call them as the gas giants, but whereas Uranus and Neptune, we call them as ice giants basically. Okay, so these how, so the if you see Mercury, Venus, Earth, and Mars, so these four are known as the terrestrial planets, and then Jupiter and Saturn, they are known as gas giants, and then Uranus, Neptune, they are known as ice giants basically. So they also, but because of far away from the solar system, so that is how these things have been formed actually. And of course all these four giant planets, they have a strong magnetic fields, and that has been measured also. Voyager 1 and other Cassini, they went, right? So they all measured this magnetic fields and others also. And these are the distances actually. And this is 5, 10, 20, 30 AUs. I already told AU means the distance from center of Earth to center of sun basically. So 5 times AU means that is a 5 times is a distance actually relative with respect to Earth itself. So this is how the diameters look like. So sun is something like this. Okay, the huge the circle you can see, the half circle. So now Jupiter is the next one in the Taylor series. Then we have Saturn, then Uranus, then Neptune, and then of course the terrestrial planets may come up, and then other small objects comes into picture basically. So you can see the details have been given, like Earth is basically Earth is some 12,756 I think units, maybe they have given the diameter or whatever here. So now you can see how large these planets are. Okay. Now, sorry. So this is how it looks. So now this is how our Jupiter looks like basically. Okay. So this was the image of Jupiter, say, that was taken by New Horizons, the aircraft. And of course now one spacecraft went to Juno, that is an orbiter. They have done some calculations or whatever. So these are the details of Jupiter. Actually, its radius is this much, then its density average basically. Okay, you will have different materials, but the average density and the axial tilt. So Jupiter is north pole, south pole is not perfect straight, it also has slightly inclined actual. Okay, so this may be the axial tilt, and then this orbital period actually 11.9 years, and then distance is 5.5 AU from sun itself. Okay, and you can see the most important thing which you see in Jupiter, say this was by Voyager 1 also, give a nice photograph of Jupiter. What's the most important thing you'll observe in Jupiter? The most important thing whenever you look at these photographs, say, what is the most important thing? Automatically our eye catches actually.
So large gaseous volcano, large gaseous cyclones.
Gaseous, but this is, you can see here, this is the most important thing. You followed. So the most important thing is this portion. You can see this is Jupiter's red eye, they say. You can see here, which has been zoomed up here. So this is a huge cyclone storm. I think the site, I think its size is I think more than Earth or something like that. Okay, and recently they have found out that the size is decreasing basically. This is a huge cyclone also. So this is one famous feature when you look from Jupiter, say, even in a telescope also you can see this, the giant red spot, which is a cyclone on Jupiter. Okay, so it looks something like this. This is a unique feature of Jupiter. Okay, and then these are the satellites basically of the Jupiter, and all of them have been photographed, and then many spacecrafts, I think 1 or 2 or 3, they went, they flown by this Cassini also while going to Saturn. It also took photographs basically, okay, of several moons also, and it has a lot of moons. I think some 6 to 7 or so many moons are there, but these are the main moons basically: Io, Europa, Ganymede, and Callistic actually. And they have found out that Io contains silicate rocks are there. In the Europa, say, it has ice, and then oceans are there. Then Ganymede, ice, oceans are there. Rocks can be found out in all these Jupiter satellites also. And now I think they are sending some missions also, NASA, some submarines here. No? They are going to, I think, Europa or somewhere to examine. People find, say, that you see there may be some biological lives, or how these oceans have formed on Europa and others. They would like to study this in more detail. Okay, and these are the Io. This is a moon of the Jupiter. So this also, and it shows a lot of volcanism. The silicate. So this Io, as already I told, it has silicate rocks basically. Okay, so it shows a lot of volcanic activity, and then volcanisms. You can observe from the, even the, you can see this plume actually. If you take a photograph, say, so this volcano eruptions, the lava almost it came up to 140 kilometer, that much plumes you can see in this Io. Okay, so these are huge volcanic activities going on. Then Europa, say, it has a lot of oceans are there. Then rocks are there. You follow it. So it's the surface has been photographed. Some impact craters also. One can see on this Europa. This is what they known as pile crater. Some photographs have come up. And these are, I think, Ganymede. So this also contains a lot of craters, rocks, oceans. Ice has been found out on this satellite also. Okay, this is a Callisto. This is also a moon on of this Jupiter. You can see there are craters are there, landslides. So from these remote sensing images, say, okay. So one can see this beautifully. All these features in these Jupiter moons. So they have generated nowadays a lot of interest, and many missions are going on. Even Europe missions, Europeans are sending. Now China has entered the race. You followed it. So like so many things are happening. So this is about the Jupiter, and of course apart from these moons, it has so many moons, and Jupiter also has small rings also. Okay, these gas giants. So now next comes is this Saturn. So as already I told you, the Cassini, say. So that I think 2 years back it gave a lot of information about this Saturn actually. Okay, so this is a radius and this is a density and this axial tilt basically, and then its orbital period 29 years and 9 astronomical units, and it has almost 150 moons basically. So many moons has been observed for Saturn. So this was a picture taken by Cassini spacecraft, for the Saturn rings, and beautifully this photograph was taken by this Cassini spacecraft. And then you can see this Cassini gave a lot of beautiful images. You can see huge storms basically. They are almost of our double or triple of our Earth planet itself. So huge storms have been observed on cyclones. This type of things have been observed on Saturn itself. And in the South Pole also, a lot of polar storms has been observed on Saturn. And now you can see this is a North Pole. Say the Saturn shows a beautiful, the photograph. So it has been nobody thought in our solar system. So generally, whenever you see a vortex, say, or the cyclones or whatever, so what type of shape the cyclones will be? No. Generally, if we see a cyclone in our Earth, generally what type of shape it will be? Cyclones? No. It will be rotating, spinning basically. What type of shapes it will be?
Circular.
Circular or elliptical.
So that is how. But can you see here what type of shape it is there? This cyclone here, North Pole.
Hexagon.
A hexagon has been seen. So now how come hexagon comes there, right? So how come these vortexes say, hexagon, which nobody you followed, right, thought about it. So this was given by Cassini 2 years back. Only people came to know that this type of hexagon also, know why, what is the reason for this. Now people are breaking their head and then trying to understand basically. Okay, so this was a very new discovery which was given by Saturn. That is essentially this is a Cassini spacecraft. Okay, so then how these rings have formed, say this also Cassini spacecraft provided a lot of information actually. So they say that these rings have formed by these comets, or maybe some moons or satellites that have been destroyed actually by some kind of impact or whatever, or maybe late heavy bombardments. They have created these type of Saturn rings also. And there are almost 62 moons have been discovered. There are so many moons are there, but their sizes are very small sizes are there. But so visually, nowadays 62 moons, they are all significant that has been discovered for Saturn also. Now these are some of the important moons of Saturn. Titan, this is a huge moon of Saturn, 5,150 kilometer, I think is a diameter or whatever is of this moon. Then Enceladus actually. So this is Enceladus. Have you heard of it? See, what's the speciality of this Enceladus? No. So this Enceladus, in this Cassini spacecraft only brought this information. So what was the speciality about Enceladus? Nobody thought before. But after Cassini, gave a lot of information actually. So what did they observe? Any of you have any idea? Like, see, Cassini spacecraft gave information basically. So what did they observe? Any of you idea? Like, see, what happened was, you can see here there's a cryovolcanism, they say. So what happened here also, a lot of water geysers basically. So what Cassini spacecraft observed was water was spilling into the the atmosphere basically. Okay, like like volcano spills up to 140, right? So here people started observing water geysers basically on this Enceladus. And what is the reason for this? People are now trying to understand on this one. And now this is a mimas basically. Okay, this also Cassini took a photograph. So you can see bullseye crater. There are so many craters are there, water ice, the full it has been observed on this mimas, and so many this Cassini spacecraft gave a lot of information about this Saturn. And Rhea, so many are there like this, Rhea. Then this is, I think, Hyperion, so this also came all this from the Cassini spacecraft. And now next comes this Uranus in the gas giants. So we are having Jupiter, then we have Saturn, and then we have this Uranus. This is also, but what's the speciality of Uranus and Neptune? Uranus, Neptune, and Jupiter, Saturn, all of them are same, or what's the difference between these two? This group, Uranus and Neptune group. I told you, right? Jupiter and Saturn, we call them as
Gas giant.
Gas giant.
Uranus and Neptune.
Ice giant.
It's because these are different type of because of far away from the solar system, say they are all, you will see a lot of ices actually, okay, on Uranus. So these are the details like radius, density, orbital period, and and this tilt is 98 degrees basically of the Uranus. Okay, I will show you some other photographs at later stage also. And then this Uranus also, Voyager and some missions went, and the photographs came. This Uranus also has rings basically, like Saturn. Jupiter also has rings. Saturn also has rings, but the Saturn rings are very bright basically. But Uranus ring also has rings, but very minor. So there are so many small objects which are circulating this Uranus. Miranda, this is a very famous moon of this Uranus. So 27 known moons are there, but apart from that, so many may be there which still people have not discovered. So these are the moons basically: Miranda, Ariel, Umbriel, Titania, Oberon, like that. Some names they have provided. So these are some of the moons Miranda, how it looks like actually. Okay, so Voyager 2 has taken a photograph. As already I mentioned, right, Voyager 1, Voyager 2, they went the solar system. So while passing away from the solar system, so they saw all these, these objects, and the pictures have been photographed and then sent back to Earth itself. Okay, so this is also one more moon, Ariel, basically. Okay, which is a moon of Neptune. Okay, sorry, Uranus. Now next comes our Neptune. Okay, this is also Voyager 2 has taken a photograph, and Neptune basically it gives the the blue light basically. It looks like blue. Okay, because of methane ices are there. So because of the lights, methane reflects blue lights. It looks in a blue color basically. Of course, Uranus also looks little bit of blue only, but these are all because of why they are looking like, as already I told you, like Uranus and Neptune, say they are all blue color, or this type of colors comes because there are a lot of ices are there, methane ice, due to that the colors are slightly different. Saturn and Jupiter, say they are all gas giants basically, so their color thing is entirely different. Okay, so this is how the Neptune looks like, and then 14 moons are there. Voyager has given a lot of information, and irregular, all kinds of variety moons are there. So this is a Triton actual, okay, moon of this Uranus, and you can see there is a lot of geysers are there, like volcano geysers, say. So mountains and other things are also there on Triton, the moons of these planets. And this is a Pluto basically. Now Pluto is no more a planet; it is what they call as a dwarf planet. But of course, now people are debating actually whether still we have to include it in a planet or not, because Pluto has a lot of geological, the formations are there on Pluto. So if you see the Pluto's topography data sets are already there. The Voyager, they have taken pictures and they're sent also. You can see a lot of mountains, ices, nitrogen ice flow. Huge mountains are there on Pluto basically. So they say that Pluto is a geologically very active thing. So maybe you can call it as a planet. So some discussions are going on. But as per the definition of that astronomical unit or whatever, so it is classified as a dwarf planet basically. Okay, so this is how the moons are there. Sorry, this is about the Pluto basically. So now this is a one moon of Pluto, Charon, they say. Okay, this is a huge moon of Pluto, and almost I think its mass is high compared to our Earth Moon kind of system, and they both rotate around some other point basically. Okay, you can see in Wikipedia, you can get these details also. Okay, so this is how the planetary system. So now so this is Jupiter, Saturn are gas giants, and Uranus, Neptune, so they are basically ice giants actually. So these are the things which are located far away, that is in outer solar system. Now when you come to the inner solar system, say, so we are having the terrestrial planets. So this is terrestrial planets, say. So now if in the Taylor series, as already I told you, first comes the Sun, then comes Jupiter, Saturn, then Uranus, and then Neptune. After that, you will have these terrestrial planets. And of course, if you go by mass, they are extremely small. The remaining debris basically, you can see less than 1/5 of the smallest giant planet, and their orbital angular moment is also very small actually when you compare with the Jupiter and others. Angular momentum, or in terms of mass, or in terms of angular momentum also. So these are extremely small itself. So now these terrestrial planets, so they are all solid bodies basically. Okay, the no gas, not like gas giant or these type of giants, but they're all made up of rocks basically. Variety of minerals, these metals and other things are there. So, and of course, and the most important, interesting thing in our solar system, say, so which is the most interesting part of our solar system? These inner planets or the outer planets? Now, which is the most interesting?
So inner planets.
Inner planets. Why?
So because they resemble our Earth. Quite a
Because
lot.
we are there, so obviously it is interesting for us. Okay, simple answer. You followed. If you say that inner solar system is not interesting, so then why are you staying? Right? Get lost, kind of thing. Okay. So anyway, so very interesting because although you are having gas giant, ice giants, is there, but if you go by biologically, Earth only is having life with it, so its significance will be. If you go by mass, Sun comes first. If you go by life, say, then maybe biological things, maybe Earth comes first. Actually, okay. So it depends. So anyway, so these inner planets are the most interesting things itself, and of course, the largest terrestrial planets are Earth and Venus, more or less same kind of thing. It will be there, like twins kind of thing. And Mars and Mercury, say, they are very small, but still they are significant terrestrial planets. And all four terrestrial planets, they have atmospheres. Okay, even Mercury, is, Venus, everything has an atmosphere. And of course it varies, magnetic field or whatever, so all those details are available here. Okay, so now this is how the Mercury, looks like. So this was a one messenger aircraft was there, okay, which was sent to Mercury. I think Mariner 10, so many things came. So now we have beautiful pictures of Mercury. So you can see how the Mercury look, it is the smallest in the solar system. Okay, that as per the diameter, and length is 88, the Earth days. And Mercury, if you see, a lot of impact craters are there. So impact crater means some meteoroids or some other materials. It has collided with this planet, and then this crater forms nicely, at this place itself. So this we call as impact craters. Okay, like meteorite impacts you would have seen, right, in Earth also, Arizona crater. In our India, we have at Lunars in Maharashtra, a huge asteroid crater is there. Okay, which was I think some 50,000 years back or something. That crater was created. Dhalo crater in India also many are there, 4-5 craters. But the problem in Earth is, what happens is once a beautiful crater is like this, because of tectonic activity, weathering of the rocks, atmosphere. So these craters, they get destroyed actually. But in these planets, so still, because of atmosphere or weathering is not there, still you can beautifully these craters, they appear nicely, in these planets itself. And then Mercury, if you see, is a lot of the lava, a lot of volcanic activities observed in this Mercury. Lava flows, lava is going, volcanic activities are continuously happening on Mercury itself. So there is a lot of the details are there, like you see volcanism. Some crater was there, say, because of volcanic activity, this crater also got destroyed actually. Okay, in Mercury also. So then magnetic field is there, all other details also are there. And now this is a Venus basically. So Venus also, more or less, same as Earth size or whatever here. And then, it doesn't have any natural satellite. But the only problem in Venus is the temperature is extremely high, 420 degrees centigrade, more than from, this Mercury itself. And one Venus thing is, and it's a very interesting thing for Venus basically. Earth, you can see here, Earth's inclination is how much here? Earth's north pole, south pole. Say, if you see here, Earth is inclined basically. Okay, 23 degrees. Our Earth north pole, south pole axis. Okay, it is like this. But Venus, what is the angle? Yeah. So Venus, can you see here how it is rotating? Venus, what is the angle?
177.
177. So Venus is something down, it rotates actually, but whereas Earth rotates like this. So generally Venus, what they say is retrograde motion, they say. Retro means reverse. See, generally whenever there is a rotation, say, Sun is the most dominating. If Sun is rotating in clockwise, say, all the planets have to rotate clockwise only. But Venus is very special because of this 177 degrees. This one, it does retrograde, the fashion. So this is a very speciality about Venus. So in our entire solar system, only two planets have they behave, differently. One is Venus, other one is Uranus. Actually, it is 97 degrees, but whereas Venus is 177 degrees. So these are two very special, things in terms of rotations. Actually, okay. So Venus is a very peculiar thing in our solar system, and of course, Venus has a lot of atmosphere and it has sulfuric acid actually. So huge carbon dioxide, the atmosphere is there. So because of this huge, this one, the temperatures are extremely high on Venus compared to even Mercury also. All the Mercury is located very close to the sun, say, because of this complicated atmosphere, sulfuric acid atmosphere, so the temperatures are 464 degrees centigrade, on Venus, very extremely high. Hot. So now this is what they say. So upper atmosphere velocity, rotational period is these are the details, and this was 90%. So these are all basaltic plains, full of volcanic activity was there on Venus, and then these lava flows, and then you see this Venus surface is like a basaltic plains. Okay, similar to our Earth, say whatever we see near volcanoes, same thing you can see on Venus also. And this is this is a Soviet spacecraft, Venera 13 or whatever. They launched it to Venus and it landed. Crash landing happened, but it sent a beautiful photograph actually of Venus. You can see how the Venus looks like. More or less, it looks the same as our Earth surface, but the temperatures are extremely the high on Venus. Now, a lot of impact craters, ground cracks. You can observe on this Venus also. You can see thick atmosphere. Okay, like observations in impact craters because of this volcanic activity and others. Some of the craters also have been destroyed basically. Okay, now comes our Earth planet. Okay, so of course we will discuss this in great detail. I will just show you. Now, what is the most important speciality about Earth? Biologically, of course, Earth is the most significant. Now, what's the other speciality?
So Earth only have tectonic plates.
Excellent, actually. Okay, so this is our tectonic plates. The plate tectonics are there. Then right, our Earth is the most dynamic planet actually. So now also plates are moving. What is the velocity of Indian plate? Can anybody tell me? India is moving, right? Indian plates. Now, what is the velocity of Indian plate? Plate velocity is there. How much it will be, like approximately?
55 mm per year.
55 mm or 5 centimeter per year. So plates, some plates will have velocities maybe, say 10 centimeter per year, or maybe as low also 1 centimeter per year. So whole Earth surface is all these things are moving actually. So this is good for one point of view, but the negative thing is they destroy all the evidences actually because of this plate movements. Okay. So these are the tectonic plates actually. Okay, like of course now there are 43 tectonic plates are there, not some people have measured all, like India Australian plates. Previously India Australia was supposed to be one plate, but now 2004 that Andaman earthquake occurred, right? So after that India and Australia has taken diverse actually. Okay, so now they started one more plate here which is cutting India and Australia. So now Australia and India have taken diverse actually. And then right now they are finding that in Africa, say a new plate is getting formed, and I think Somalia or something, it will hit India basically. Maybe we may become as a one plate maybe after some point of course millions of years. That is going to happen. Now similarly, say so we are having subduction zones, volcanic activity, like you have seen, right? Recently, where was that volcano? Anybody tell that name of a volcano? Last week or maybe huge.
Tonga. Tonga.
So that volcano erupted in ocean actually. That has created, we have recorded the data also, that data is also available. The P waves, very nicely they have been recorded in the whole global seismograph networks. So our Earth's thing is volcanoes are there, plate movements are there, all kinds of geologically very, very active, the planets. So this is a barren islands, right? Barren islands is there in our Andaman place. We have volcanoes, okay? So of course, Italy, everywhere volcanoes are there, but this is a volcano in our, India, that is in this barren Andaman region. Okay. Now, of course, in our Earth, we have even continent also collisions, like Indian plate collided with the, this Asian plate, and then you will see Himalayas. Mountains have been formed because of this collision process, and all kinds of things you can see in our Indian plate also. Okay. Now this is the Mars basically, in the last terrestrial planet. So you can see this is a Mars, and Mars has several moons, but two moons are there. One is a Phobos and then Deimos. I think Phobos, our ISRO they have sent one Mars long back. They have taken excellent photographs of this. I think Deimos moon also. Even our ISRO also has taken the nice photograph. Of course, US they have done Latin. So many missions have been sent to Mars also. So this is how it comes: Moon, Venus, and Mars. How they appear in the sky. So if you see night, evening, our sky, you can see Mars nicely in the sky. Venus also is a very bright spot. Okay. And now this is how the this is Earth, this is Moon, and this is Mars. Their sizes actually relative sizes basically. So Mars is much smaller than our Earth itself. Okay. And Mars previously, Christian Huygens, that simple harmonic motion fellow, many people from long back, they were using telescopes actually. They gave some approximate how Mars looks like the surface, they identified some places, what are the places on Mars. So these things have been long back, people try to attempt actually from the olden days itself. And Mariner 4, it gave the first image of Mars actually. And then the Viking lander, right, in 1976 it landed on Mars, and this was a photograph actually which was sent from the Mars. Okay, now of course these are the details. If you want to compare Earth and Mars, say, so Earth's inclination is 23.44, but Mars is 25.19 actually. The inclinations are more or less close to each other itself. And this is atmosphere detail. So this has like it's oxygen, say our Earth has a 0.2% or whatever, but whereas Mars has very little the oxygen itself. So these are some comparisons actually. And then if you see in Mars also, you will see a lot of volcanic activity. Lot of basins has been done, flooding actually. Okay, like a huge lakes were there, lake basins, all those things you can see on Mars itself. Like most fluidized ejecta are there, volcanic activity, everything you can see on Mars. Beautiful photographs. And then you can also see like rivers, and then people have found out that rivers were flowing on Mars basically. Okay, once upon a time, and you can see these beautiful river networks also. Like you can see exactly like our Ganga River or tributaries and other things. You can see the same features on Mars itself. And then you can see this type of glacial, the lakes also, lake groundwater also. You can see all these geological features on the deltas also on Mars also. But right now there is no water there, but where it has gone, no idea. Still research is going on. But all the geological features is similar to Earth, one can see on Mars also. Then there was also one more important paper. They said that Mars had an ocean actually once upon a time. The ocean shorelines have been paper has been published also, but where this water is we don't know. But all these things have been photographed, and people have done research, and many papers have been published also. So you can see this is a glacier actually. Okay, it is in Alaska. You can see in Mars also, you can see these type of glacial things. But one can see these type of geological formations on Mars also. Okay, and of course Mars has ice, all of right, H2O and then carbon dioxide ice set. The full north pole is covered with ice also. Okay, so this also they have found out actually. And then gullies, channels, fan sections, all these things you can see. And you can see curiosity, you know better. Okay, you can go to Wikipedia and you can see a lot of Mars thing photograph is like this, Earth is like this, exactly same to same. The lake features, lake beds, you can see all these details from these rovers. Sedimentary rocks are there, sand dunes are there, like a desert, say. So all these details, you can have these beautiful sand dunes on Mars also. Okay, dust storms are there. You would have seen in that movie also, right? Huge dust storms, anything you can see, and volcanisms, and the largest, highest, I think, the volcano, right? Olympus Mons actually. This is the largest, I think, volcano in the solar system, they say. But of course, we don't know about other regions. But this is right now, the huge mountain basically, okay, which has been formed due to a volcano. Okay, so a lot of tectonic activity also you can see. The huge tectonic feature is Valles Marineris actually. Okay, so this is a huge 4,000 kilometer, like a Grand Canyon. Say you can see directly from the spacecraft actually on this Mars also. Okay, so anyway, so I will stop here. We will continue in our tomorrow's class. So I will give you some more brief details, and then we will examine what are the important things in planetary exploration before we go into our stress strain, the geodynamics modeling itself. Okay, so if you have any questions, you can ask me.